Hello guys, welcome back to algebra class. And this time I will go over this transformational graph for absolute value. But before we actually go over this transformation, I want to go over some analysis part here. So let's do this. We have an absolute value graph here that is given to you. And now I want you guys to find the solution. Solution means x-intercept. So in this case, we have 2 points, right here and right here. So negative 5, 0 and negative 1, 0. Now what's the y-intercept? It's right here, which is 0, 1. Axis of symmetry. This one is a line that cuts this graph in half like this. Do you see this line make this graph symmetric to each other? That's axis of symmetry. And look at this. This graph touches where x is equal to negative 3. So this one is x equals negative 3. Now what's vertex? Vertex is this point here. So vertex is always highest or lowest point, and that's the point. So we have to write the coordinate, which is going to be negative 3, negative 2. Now domain and range is going to be the trickiest part, but if you look at the domain, this one does not stop, it's keep going to the left. So I start from the negative infinity and less than, x less than. Always you put less than sign here, okay? And it's keep going to the right. So this one goes all the way to the infinity, okay? Now let's talk about the range. Range is the y value. And unlike domain, we're going to start like this. Range is the bottom to top. So our lowest point in this case is going to be, this graph is keep going down, but stops here and going back up. So here, negative 2. That's the lowest point of the y. And since it is on the line, I'm going to put less than or equal to like this. You're going to put y less than. What's the highest point? It keeps going up all the way to infinity. So that's what you do here, okay? So I want you guys to try these questions by yourself. I believe this one should be easy. Maybe the parts you may make mistake last, okay? So pause the video and do it by yourself. All right, now check your answer. It's going to be negative 2, 0 and 8, 0. It's going to be 0, 2. Axis of symmetry is this one, which is x equals positive 3. Vertex is this point, which is 3, 5. Domain is same thing, negative infinity to positive infinity. Now, if you look at the range is the bottom to top. So unlike here, this one, the lowest point is keep going down, right? So you start from negative infinity. And the highest point is keep going up, stops here, and goes back up. So here, that's the highest point, which is 5. And do you see I put less than or equal to here because it is on the line. So that's a graph analysis part. Now let's talk about the transformation of graph. But here's some things that you might have to know. So what you have to know is if A is greater than 1, then we call it vertically stretched. And if A is smaller than 1, we call it vertically compressed. Now, H works opposite direction. If it is negative, it moves to the right. If it is positive, it moves to the left. It's kind of weird, right? But if you have a question, I can explain more details later. Not in this video. K, so goes as its sign. So it's up and down. So if it's plus, we call it up. If it is minus, we call it down. So only thing that is going to be weird is going to be this, but it's not very difficult to memorize. The hardest part is going to be, in fact, this one. So let's look at it. Given the absolute value function below, which is this, explain the transformation of the absolute value graph from its parent function. So question is, what is parent function? So do you see I had a graph here? So here, parent function is absolute value of x. Now, if you don't know where I can find this absolute value, it's right here above ABC. If you look at Desmos, one that I'm keep clicking, this one, okay? So that's a parent function. And now I'm going to put this one in. So first, absolute value of x, let me put minus 4. Can you see from the compared to green, it moved to the right. So this one is 4 units to the right. Minus 7, if I put minus 7 at the end, do you see it moves down? Supposedly it should move 7 units down. So it's like that, 7 down. That's it. So try this question by yourself. That's easy. And now let's go to here. It's the same thing here, but watch. Do you see there's a 3 in front of x? So I'm going to put 3. And do you see your new graph, the purple one, got narrower, right? That means that's because we stretched it, not horizontally, but vertically. So we call it vertically stretched by 3. And if you put plus 1, do you see it moves 1 to the left here? So you're going to put 1 left. And minus 4 should be 4 down. Minus 4. Do you see? And then it moves 4 down. That's what you have to know. What about next one? If you look at 1/2, now do you see compared to grid now this one got wider? It is because you compressed it vertically. So we call it vertically compressed by 1/2. And minus 3 and minus 4 should be the same thing. You just put minus 3 here. That's 3 to the right. And minus 4 at the end should be 4 down. Okay? So do not count the grid on the decimals here. Just look at the number and figure out how many units it has moved. Okay? Here, this is the last question that I want to go over. It says -2, right? Now watch. -2 is smaller than 1, so it sounds like this one should be compressed. But watch what happened. If I put negative, do you see this graph flipped? And if I put 2, it got narrower, which means stretched. Why did it happen? It's because we don't care about the negative. Because do you see this negative? Negative is just reflect. Do you see graph got reflected? That's why. And only thing that we care is this 2. So sign doesn't matter. Now 2 is greater than 1, so that's why we call it vertically stretched by 3. And obviously if you put plus 3, that moves 3 to the left, so you're going to put 3 left. So that's about it. I believe this lesson should be easy. And if you have any questions, just let me know. Then I'll give you more detailed lesson. My classroom is at B221. All right. That's it, guys. See you next time. Bye.